So what we were doing at the end of class on Monday was it was giving us some zeros. We were working backwards, turning those zeros of the function into factors. And then we were multiplying those factors together to get the whole list of terms, the whole polynomial function. So we're going to continue with that on number 11. Now, remember, when you have zeros that have i's or square roots, they come in pairs, right? If positive 3i is a 0, and so is negative 3i. If positive square root of 7 is a 0, so is negative square root of 7. They come in pairs. So on number 11, it says find a polynomial function of the lowest degree that has the given numbers as sum of its zeros. So it gives me the square root of 3 as a 0, and it gives me 3i as a 0. But remember, both of these, since one's an I and one's a radical, come in pairs, right? Which means if positive square root of 3 is a 0, so is negative square root of 3. If 3i is a 0, so is negative 3i. So I know that this one has 4 zeros. So now, working backwards, I've got to turn all of those zeros into the factors that they would have come from. Now remember, if you're turning a 0 into a factor, it's always x minus whatever the 0 is. That's how you turn it into its factor that it came from. That's why this one would have come from the factor x minus the square root of 3. That's why this one, if you did x minus negative square root of 3, that's why this one really would have come from x plus the square root of 3. This one would have come from x minus 3i, and this one would have come from x plus 3i. So remember all that foiling that we did on Monday. We're doing some more. Now, here's the thing. Remember that these factor pairs are conjugates of each other. You want to always multiply conjugates together because they clean each other up. A lot of stuff cancels. It makes things not have i's anymore or square roots anymore. It kind of makes the problem look better. Also, remember, I'm going to multiply these conjugates together. These are also conjugates, right? You're a conjugate if everything's the same except your sign in the middle. So these are also conjugates of each other. So I'm going to multiply those together, which means I'll get 2 answers, one from multiplying there and one from multiplying there. Then I'll multiply those answers together. Now, when you're multiplying 2 binomials together like this, don't a lot of people call that FOIL? They're going to FOIL that. Now remember, first, outer, inner, last is what FOIL stands for. When you're multiplying conjugates, this is why they clean each other up. Let's look at our first. What's x times x? X squared. Every single time, your outers and your inners, when you're multiplying conjugates, are going to cancel each other out. Don't write this down because it's going to cancel it out anyway. So again, don't write this down. What is positive x times the square root of 3? Positive x square root of 3. Your inner would have been negative square root of 3 times x, which would have given me negative x square root of 3. What happens to those? They cancel. So that's a good thing about multiplying conjugates is you can really do your first, skip your outers and inners because they're going to cancel each other anyway, and jump straight to the last. So you can kind of leave out part of FOIL, right? Because the outers and inners are going to cancel each other anyway. So I did my first. X times x gave me the x squared. I'm going to jump straight to my last. Negative square root of 3 times positive square root of 3 gives me negative square root of 9. Here's the other good thing about multiplying conjugates that have square roots. What is the square root of 9? That's just the same exact thing as just saying 3, isn't it? So just write that as a 3. So all you're left with from this up here is just x squared minus 3. I'm going to multiply this conjugate pair together. So again, since they're conjugates of each other, the outers and inners of FOIL are going to cancel each other. So you might as well just do your first, x times x, which gives me x squared, and then just jump straight to your last. You have negative 3i times positive 3i, which is negative 9i squared. But remember what I squared is equal to. It's equal to negative 1. So this really says x squared. If that's negative 1, I have negative 9 times negative 1, which actually makes it plus 9. So all that's left from that one is x squared plus 9. Then multiply those together. X squared times x squared gives me x to the 4th. My outer, these are not conjugates of each other, right? They're not the same with a different sign in the middle. So I've got to do all of FOIL because those outers and inners won't cancel. They only cancel if they're conjugates. So since those aren't, I've got to do the whole thing. So my outer, x squared times positive 9 is positive 9x squared. My inner, negative 3x squared. And my last, negative 3 times positive 9 is negative 27. Combine your like terms in the middle, right? These are both x squared, so I can just put them together. So I've got x to the 4th. 9x squared minus 3x squared is positive 6x squared minus 27. So there's the polynomial function that would result from those 4 zeros. Number 12. F of x equals, it says, here's the polynomial function, then it's going to give me one of the zeros from that function and ask me to find the others. So the polynomial function that it gives me is f of x equals x to the 3rd plus 7x squared minus 2x minus 14. And it tells me one of the zeros of this function is negative 7. Now remember what zeros are. Zeros are places where the function crosses or touches the x-axis, right? X-intercepts are what the zeros are. So it wants me to find the other ones. So, and it's going to have 3, right? That tells me the maximum number of zeros it's going to possibly have is 3. So let's see, there's several different ways. I could maybe put this in my y equals and just see if I can see where it crosses or touches the x-axis. That sometimes will work. Let's put it in here. Y equals, clear it out. I'm going to put this function in there. X to the 3rd plus 7x squared minus 2x minus 14. And I'm going to graph it. Now remember, it's already told me that -7 is a 0. So it should be crossing at -7. Next to the third. Oh, I got my 7. Okay, so it should, right? It told me that -7 was a 0. So you can see there it crosses -7 on the x-axis right there. There's the other 2 zeros. Unfortunately, those aren't good ones. By good, look, can you see what hash mark that's on? No, because it's in between 2 hash marks. There's no telling. It's in between -2 and -1. That one's in between +1 and +2. So I can't see it like I can see this one crosses right through at -7. So I'm not going to be able to eyeball this. Okay, there's other ways to do this. I can do it by factoring this. So if I factored this, it's factoring by grouping, because there's 4 terms. There's 4 terms, nothing's in common here, so I can't pull anything out. If you're going to factor by grouping, that's actually going to find all of your zeros. So if I put these first 2 in a group, right? Because if I can factor that and find its factors, can't I just set the factors equal to 0 and solve them for x? That gives me all my zeros. It has to be factorable. So let's see. What is in common in my first group here? X squared, right? I can pull an x squared out of both of those. If I pull x squared out of both of these, what's going to be left? You just divide by whatever you pull out. So let's see. If I pulled x squared out of x cubed, I'll still have an x. Plus, if I pulled the x squared out of this term, I'll still have the 7. Do the same thing in that second group. What's in common with this second group? They both divide by 2. If your leading term is negative, you're going to pull that out too. So I'm pulling out a -2 from both of these. Let's see. I pulled the -2 out, so I'm just left with x. If I divide this by -2, I get +7. When you're factoring by grouping, these 2 things have to end up being the same, which they are. Here's your factors. Your matching pair is 1 factor. What you pulled out is your other factor. So let's see, x squared minus 2. That one's good to go. That's going to give me 1 0. It's going to, unfortunately, it's just going to give me the 0 that it already told me it was a 0, right? If I set that equal to 0 and solve it for x equals -7. I already knew that was a 0. If I set this equal to 0, x squared minus 2, this is not an equation like this. It's not just solving for x. It's got an x squared, but where can you solve all x squared equations? What do we call them? Quads. Or quad, and how many answers do quad equations give you? 2. That's going to give you your other 2 zeros. Just plug it into your quad program. So go to program, down to quad. Put in your A, B, and C. What's A? What's in front of x squared? 1. Be careful here. What's your B? B is what comes in front of the x, which in this case would be 0, right? Because there's not an x. And your constant is -2. There's your other 2 zeros, a funny decimal. So I hit enter again. What are your other 2 zeros? positive and negative square root of 2. Are your other zeros. So it told me -7 was. The other x-intercepts are positive square root of 2 and negative square root of 2. Now go back to hit graph. Those are those zeros. In the square root of 2, somewhere in between 1 and 2. Yeah. Go ahead. My A is the number in front of x squared, which would be 1. Your B is the number in front of x. There is not an x here. So that's why your B is 0. Your C is your constant, which is -2. Number 13. 13. All right, for the following polynomial, 1, 0 is given, find the others. Here's the polynomial. P of x equals x to the 4th plus 27x squared minus 324. And it tells me 6i is a 0. Okay? I'm actually going to put this one in my calculator and see if I can eyeball anything. What's the maximum number of zeros that I can have? 4. So let's see if I can find any zeros by eyeballing this. So go to your y equals, clear it out, and put this function in. X to the 4th plus 27x squared minus, bless you, 324, and let's graph it. Ooh, that looks nice. That looks nice. What does this look like it's at? 3, and what's the other one look like it's at? -3. So say you're not 100% for sure. What is, when you are an x-intercept, you are an x-intercept because that's a point that hasn't gone up or down. It's still on the x-axis. What is your y coordinates at every x-intercept that's ever going to happen? They're zeros. So go to the table and see when x is 3 and -3, see if the y's that go with those are zeros. So second table, there's -3. So yeah, it is an x-intercept because its y is 0. +3, yes, it is an x-intercept because its y is also 0. So that means 3 and -3 are also zeros. What's the max number again? There's 3. But if this is a 0, what else automatically is? Right? I's come in pairs. There's your 4 zeros. That is at a very abbreviated, there's another way to do this by performing long division and all kinds of crazy other steps, which is how Math Lab would explain it. But we eyeballed it because we're using our critical thinking skills and hoping that we can eyeball some x-intercepts because we know zeros are x-intercepts. So if we can eyeball it, why go through all those steps? You're going to get the same answer. It means the same thing. So so these I could physically see, right? The 3 and the -3 x-intercepts. These, I couldn't see those. Those are i's. right? They're imaginary. Those aren't actual x-intercepts. They're zeros of this function, but I couldn't see them as x-intercepts because they're i's. Okay? So just use their critical thinking skills on that to just try and eyeball it, see if that's going to work. If not, you're going to have to go to another method. The other method on this one would have been to do some crazy long division. Okay, now, before the TI 84s and 83s came out, if you were given a polynomial function and asked to find its zeros, there was a long drawn out way that you had to go about doing that. Okay, the way that you would have to have done it, and this is on number 14 and 15, is this. If that was your polynomial function and you were asked to find zeros or x-intercepts, but you didn't have a graphing calculator and you didn't graph this, the way that you would have started this problem, you would have had to come up with all of the possibilities of zeros, right? The maximum number is only 3. But there's way more than that possibilities of things that you would have to check to see if they were zeros. And here's how you would have to do that. Right? All the factors of this last number, don't worry about the sign. 15. Factors of 15 are 15 and 1. The other factors are 5 and 3. Right? That's all the numbers that go into 15. Make another list over here of all the factors of the first coefficient, the leading coefficient. So 22 and 1. And the other factors of 22 are 11 and 2. So here's how you come up with the list. Now this is multiple choice, which is great because we're about to see all this stuff we're about to have to write out. The way you find all the numbers that you would have to check to see if they were a zero is the plus and minus every time of each of these over each of these. So just start with the top one. 15 over all of those. So, and it's plus and minus every time. Plus and minus 15 over 22, plus and minus 15 over 11, plus and minus 15 over 2, and plus and minus 15 over 1. And what is 15 over 1? Just 15, right? Those would be your first possibilities. That's actually 8 different numbers, right? Because each one is positive and negative. So that's 8 different possibilities of zeros. Then make the 5 be the numerator for everybody. So plus and minus 5 over 22, plus and minus 5 over 11, plus and minus 5 over 2, and plus and minus 5 over 1, which is just 5. So there's 8 more possibilities of zeros. Start all over. So this time I'm going to use the 3 over all those. So plus and minus 3 over 22, 3 over 11, 3 over 2, and 3 over 1, which is just 3. And then the last one. The 1 as the numerator for all those. So 1 over 22 plus or minus 1 over 11 plus or minus 1 over 2 and plus or minus 1 over 1, which is just 1. So luckily for us, this is multiple choice. So just make sure it's always the last number that makes this side. The leading coefficient makes the denominator side. And it's always plus and minus of each one. So those would be all of the numbers that could possibly be zeros. And then you know how you narrow it down to actually find the 3? Synthetic division for every single one of those options. Let's see, there was 8. Wait. Yeah, 8, 16, 24, 32 options of zeros. But only 3 of them are really zeros. So every single one of those numbers you would have to do, remember the synthetic division method? You'd have to perform synthetic division on all of those until you found the 3 zeros, which means the end of a synthetic division that didn't have a remainder. That's how you would have found the x-intercepts back in the day. Number 15 is the same kind of problem. F of x equals 16x to the 6th minus 17x to the 3rd plus 10x squared minus 18x plus 5. So there's my polynomial function. It wants me to find all the possibilities of rational zeros. So remember, this is the number that makes your numerators. Luckily, it's a 5. What's good about 5? There's its only factors. 16 has several more. 16 and 1, 8 times 2, and then 4 times 4. There's no reason to write your 4 twice, right? Those are all the factors of 16, which means all my rational zeros, all my possibles, put 5 on top of all those. Always plus and minus. So 5 over 16, 5 over 8, plus and minus 5 fourths, plus and minus 5 halves, and plus and minus 5 over 1. And then do the same thing and put the 1 over all of those. So plus and minus 1/16, plus and minus 1/8, plus and minus 1/4, plus and minus a half, and plus and minus 1. So those are all of your possibilities of zeros. All right, number 16. Find all the rational zeros and any other zeros of the function f of x equals x to the 3rd minus 57x plus 56. So if I'm finding zeros, the luckiest that you're going to get is if you can eyeball them, right? That's going to be the easiest thing to do. So let's see if we can eyeball any zeros of this function. So put it in your y equals. So y equals x to the third minus 57x plus 56 and graph it to see if you can see any numbers that might be zeros. I see several that look good to me. Let's see, this one looks like it might be at negative 1, 2, 3, 4, 5, 6, 7, 8. I'm going to try negative 8. I'm going to put up what I think is possibly done. And then I'm going to look at my table in a second. That one looks like positive 1. 1, 2, 3, 4, 5, 6, 7. So it looks like also at 1 and 7. Okay? Now remember, you're just eyeballing this, which means just because it looks like it goes through a hash mark doesn't mean it necessarily 100% does. How do you check each one to see if those actually are zeros? Go to your table. Because if you're at x-intercept, your y-coordinate should be 0. So let's look at all those x's that I just put on the board. So negative 8. Look at negative 8's y-coordinate. It is a 0, which means that is an x-intercept. Let's look at 1. 1's y-coordinate. Yep, that's a good x-intercept. And 7. 7's y-coordinate is also a 0, which means I looked at the graph of the function, saw where it looked like it crossed the x-axis and wrote those numbers down, then checked those numbers in my table to make sure that their y-coordinates were zeros. And I don't worry about there being any more, because what's the maximum number of zeros that this function has? 3, and you just found them. So on this, there are only rational zeros. They're negative 8, 1, and 7. Now, the second part of this, look down at the very bottom part of that question. It says the factorization of f of x into linear factors is blank. Well, if these are your zeros, remember how you go from zeros to factors? If this is a 0, what factor did it come from? X plus 8. If this is a 0, that's an x-intercept. That means its factor was x minus 1, and this one was x minus 7. If you FOILed all this together, you'd come up with that. So that's what you learned by eyeballing those x-intercepts on the x-axis. Check them in the table to make sure they really were. So there's your zeros, and there's the factors. We're not always going to be that lucky, like on number 17. And 18. Number 17. Why were we lucky on this one? Because I could eyeball it. That is what makes you lucky. Let's look at 17's function. F of x equals 2x cubed plus 5x squared plus 50x plus 125. Let's try to eyeball that. So go to your y equals 2x to the third, 2x to the third plus 5x squared plus 50x plus 125, and graph it. I'm only seeing it cross the x-axis one time. And is this a good one? Does it cross through a hash mark? No, it looks like it crosses somewhere between -2 and -3. So I can't eyeball this and say, this is for sure an x-intercept or a 0, which means I have to do something else. So remember, another way to find 0, if I can find factors, I can set my factors equal to 0 and solve them for x to get zeros. So let's see about factoring this. I can either use factoring or some kind of synthetic division, but let's use factoring since I don't know any zeros. How many terms are there? 4 terms. There's nothing in common with any of those 4 terms. So we did this a little bit earlier. If there's nothing in common with the 4 terms and you're trying to factor them, put them in groups of 2. And do greatest common, what's in common in each of the smaller groups. This first group, nothing goes into 2 and 5, but they both have at least x squared. So I'm going to pull out an x squared. What's left if you pull x squared out of each of these? Let's see, I'll still have a 2. If I had x cubed, but I pulled out x squared, I'll still have an x. Plus, here, if I had x squared, but I pulled it out, so all I'm left with is the 5. Now I'm going to pull out the greatest common factor of this second group. And remember, when you're factoring by grouping, you want this second parenthesis to be exactly what that first one was, because that's going to be one of your factors. What's in common? What's the greatest number that goes into 50 and 125? Positive 25 will go into both of those. So divide them both by 25 and see what's left. 50 divided by 25 gives me 2. Still have that x. Plus 125 divided by 25 is 5. So one of my factors is 2x plus 5. Remember where your other factor comes from when you are factoring by grouping. It's these terms that you had pulled out. That's your other factor. So there's your factors. Set them equal to 0 and solve them for x. What's the max number of zeros I should be looking for? 3. I only have 2 factors. But look at this one. It's a quad factor, which means when I solve it for x, it's going to give me, when I just put it in my quad program, it's going to give me 2 answers from this factor, right? So let's see. This one's just going to give me 1. I need to set it equal to 0, solve it for x. So just get the x by itself. So add the 5 to both sides. So 2x equals 5. Divide that by 2. So x equals 5 halves. There's one of your zeros. That's the one that I can see, right? The one that you can see, what is negative, or excuse me, what is, oh, what did I do wrong? Right, plus 5. This needs to be plus 5. When I set it equal to 0, I don't know why I changed it. So I would have had to do what to solve it? Subtract the 5 from both sides. So negative 5 halves is one of the zeros. That's the one I can see, right? What is negative 5 halves if you turn that into a mixed number? Negative 2.5. Look where that crosses. Right in between negative 2 and negative 3, which is at negative 2.5. This is going to give me my other 2, right? If I set this equal to 0 and solve it for x, I'm going to use my quad program to do that. Since it's x squared, be careful with your A, B, and C. A is what's in front of x squared, which is a 1. B is what's in front of x. There's not an x, right? I jumped straight from my squared to my constant. So your B is 0. Your C is 25. There's your last two zeros. Positive 5i and negative 5i. So your 3 zeros. This is one on here. It's a multiple choice, right? There's only one rational 0. That's the negative 5/2. That's the one you can see on the graph. The other zeros are 5i and negative 5i. Then it wants you to write out, after you write out the zeros, it wants you to write out the factorization. 3 zeros means 3 factors. If 5i is the 0, its factor was x minus 5i. That one's x plus 5i. Uh-oh, negative 5/2. Where did this come from? Where did this 0 come from? What was the factor that it came from? 2x plus 5. Last one. All right, last one, same thing. F of x equals x to the 4th minus 10x to the 3rd minus 66x squared minus 94x minus 39. So once we defined its zeros, there's going to be a maximum of 4. So I'm going to try to eyeball it first, see if I get lucky. Put it in your y equals to do that. So I have x to the 4th minus 10x to the 3rd minus 66x squared minus 94x minus 39, and let's graph that. Now remember, you're an x-intercept if you cross or touch the x-axis, right? Looks like it crosses there and touches there. I think I see 2 good possibilities. It looks like maybe -1 and maybe -3. So to be for sure, I'll just look at my table and see if the y coordinate at those 2 x's is 0. So go to second table. There's your -1. Yep. Its y coordinate was a 0, so that is definitely an x-intercept. There's your -3. Yes. So there's 2 of them. Now I just got to find the other 2. I'm actually going to use synthetic division this time to do that, because I don't know how to factor that. These are zeros. Do synthetic division. Now remember, when you do synthetic division, your answer is actually what comes up at the bottom. Let me show you what I'm talking about. Do either one of those. It doesn't matter which one you do first. I'm going to do the -1. Now, remember back to synthetic division. I'm just going to put the coefficients of each of these terms in here. So this one's coefficient is a 1, -10, -66, -94, and -39. Remember, if this is a true 0, which it is, I shouldn't have a remainder at the end, right? That's what makes it a 0 proven by synthetic division. It doesn't have a remainder. So These numbers that I get here are going to be the answer to this synthetic division problem. So remember the process. You'll just drop down that first number. You'll use this -1 to multiply times 1. Put your answer there. So -1 times +1 is -1. Combine those straight down, which gives me -11. -1 times -11 is +11. If I combine those straight down, I get -55. -1 times -55 is +55. If I add that straight down, I get -39. -1 times -39 is +39. So I do get a remainder of 0 right there. Now, here's the thing. On synthetic division, these numbers right here represent your answer. If you divided that, it's this. These are the coefficients of the terms of your answer, starting 1 degree less than what this one started with. So this is actually x to the third minus 11x squared minus 55x minus 39. So that was a 0. Well, if -3 is also a 0 of that, it should also be a 0 of this. So I'm going to do synthetic division again with these coefficients. So again, I should get a 0 as my answer. Use these coefficients now. 1, -11, -55, and -39. Let's do synthetic division. Bring down my 1. -3 times 1, -3. -11 and -3 is -14. -3 times -14 is +42. Straight down gives me -13. -3 times -13 is +39. There's my remainder 0. So those really are zeros. We just proved it with synthetic division without getting a remainder. We also saw it on the graph. We saw it in the table. We've seen it 100 different ways. What does this tell me down here? What's left after I took out the -1 and the -3? If I started with x cubed, what's this? X squared minus 14x minus 13. How can I find the other 2 zeros? Quad. It's x squared. Might as well use my quad. Your A, B, and C are, A would be 1. B is in front of x, so it's -14. C is your constant, which is -13. There's your crazy decimal. Hit enter again. So your other 2 zeros are 7 plus the square root of 62 and 7 minus the square root of 62. So your 4 zeros were -1, -3, 7 plus the square root of 62, and 7 minus the square root of 62. So you would choose B again. Your rational zeros are -3 and -1. Your other zeros are 7 plus and minus the square root of 62. Now you're going to have to write out the factorization. Now, remember, the factorization always is x minus whatever your 0 is. That is why, if your 0 is -1, think think about it. If you typed in x minus -1, what does that really say right here? That's why it always just looks like the sign's changing, right? Because it's always, your 0 is just x minus whatever your 0 was. So that's why this one's factor is x plus 1. That one's factor is x plus 3. Here's why I'm saying all that. This one's factor. Your factor is always x minus whatever your 0 is. So this one's factor would be x minus 7 plus the square root of 62. And this one's factor would be x minus 7 minus the square root of 62. Which is why we don't know how to factor that, right? If you're coming up with this as your factors, I don't know how you're getting there. Okay, so there's your 4 factors. There's your 4 zeros. You started off by eyeballing. We got lucky and found 2 good ones. So we used those with synthetic division twice, because that took us from being x to the 4th to x to the 3rd, then to x squared. Once we got to x squared, that meant we could find the last 2 using quad. Okay, so again, I am going to send you